you integrate with respect to y rather than x. In other words, you're going to have to rewrite your functions y of x in terms of x of y. In other words, what you're going to have to do is you're going to have to solve each of the equations for x and get them in the form of x equals. So we still have to make sure we have two functions that are continuous over a closed interval, and suppose that one of your functions, y of y, is greater than or equal to v of y. What this means, instead of looking at the curves in terms of top minus bottom, you're going to look to the fact that w of y lies to the right of the curve v of y. So in other words, instead of doing a top minus bottom, you're going to look at your curves in terms of right minus left when you want to go to calculate the area between the curves. So again, if we have some area where w of y is greater than v of y, and the area region bounded on the left by x equals v of y, and on the right by x equals w of y, then we can calculate the area. Again, we're going to still integrate the lower bound to the upper bound. Now, in this particular case, when we're integrating with respect to y, these bounds are now y values. And that's why on that previous problem I got in the habit of always writing the x and the y coordinate when I calculate the points of intersection. Again, so when we're looking at the integration, we're looking at integrating w of y minus v of y dy. And again, what we're doing is we're looking at this in terms of the curve on the right minus left. So here's an example of what a graph could look like that you would see it would be very difficult to do a top minus bottom. So this is a case where, again, notice the lower bound is c, the upper bound is the d value. So those are going to be the bounds for your integral. The y value that's on the bottom, that would be your lower bound. The y value that's on the top, that would be the upper bound of the integral. Again, take your pencil, put it on the curve that's furthest to the right, and draw it perpendicular to the y-axis. That will help you identify what curve is furthest to the right. Okay? Again, when you're doing right minus left, you just have to rewrite the equations in the form of x equals. So you may have some algebra to do to solve each of those equations for x. So for example, let's take a look at y equals the natural log of x and y equals x minus 2. Find the area of the shaded region by integrating with respect to x and integrating with respect to y. Sometimes the graphs could be done either way, but in the directions they may be very specific to integrate with respect to x, integrate with respect to y. If they don't tell you, then of course it's an eeny, meeny, miny, mo. You can find the area any way that you want. So let's just take a look at part A. So we're going to integrate with respect to x. So we've already got the equations in the form of y equals. What we have to do first of all is you have to find your points of intersection. Again, this is a calculator question, so again, I'm just going to go to my calculator and go to the y equals, type in ln of x under y1, type in x minus 2 under y2, and again, notice that I'm no longer just in the first quadrant, so again, I'm going to change my window. I'm going to make this window my x min 0 to 10, and I'm going to take this negative 10 to 10 for my y min and y max. Okay. So I'm going to go ahead and find my points of intersection. So I've got 2 points of intersection to find. Again, doesn't matter which one you find first. So this one is 3.1462. And then the y value is 1.1462. You want to take these out at least 4 decimal places because remember you are going to be using these as your bounds. So you do want to take them out at least to about 4 decimal places to get a much better accuracy for the area. And then to find the other point of intersection, point 158 1.86 and negative 1.841. Okay? So any questions on finding the points of intersection? So now when I do the area with respect to x, remember it's always going to be the top minus the bottom. So if you look right here, you can see that this function right here is the one on the top. So again, remember my functions, I'm just going to relabel this. F of x is equal to the natural log of x. G of x is equal to x minus 2. And again, I have this one loaded under y1 on my calculator and this one loaded under y2. So which function is on the top? Is it my f of x or is it my g of x? F of x, exactly. So again, to calculate the area is then going to be my integral from my lower bound of 0.1586. Again, remember the bounds are in terms of the x coordinates because I'm integrating with respect to x. And then 3.1462. And again, it's going to be the top minus bottom, so f of x minus g of x dx. So any questions on how I have that integral set up? So again, I'm going to go ahead and integrate. Again, I've got natural log of x loaded under y1, so it's going to be a y1 minus y2. So to what, about 1.949. And this is where, guys, it becomes really critical to make sure that you're loading your functions under y1 and y2. Because again, you're going to be loading lots of different functions in your integral. You don't want to make a careless mistake with parentheses, especially when you get into volume where you're going to be squaring. So it's much easier to make sure you're not making a parenthesis error to load those functions under y1 and y2. So any questions on part A? So now let's take a look at part B. So for part B, they want us to integrate with respect to y. So to integrate with respect to y, this is where, remember, you're going to be doing a right minus left. So the first thing you have to do is you have to take your two equations and you have to write them in the form of x equals. So you have to solve for x. So let's take a look first of all at y equals the ln of x. How would I solve y equals ln of x for x? What's that going to be equivalent to? E to the y equals x. So that takes care of my first one. My second one is y equals x minus 2. So again, it's going to be y plus 2 is equal to x. So again, I'm going to call f of y is equal to e to the y. G of y is equal to y plus 2. So now remember, if I'm going to do a right minus left, what I want to do on the graph is I want to identify the function that's furthest on the right. So take my pencil and draw a perpendicular line with the y-axis. As you can see, the function that's furthest on the right, it's not that ln of x, but it's that x minus 2 line. So then this is going to be the function on the right, which is my y plus 2. So then when I go to calculate the area with respect to y, again, I'm going to integrate. Now remember, your bounds now have to be the y coordinates. They are in terms of y. So the lower bound is going to be a negative 1.841. The upper bound is going to be that 1.1462. And again, it's going to be my g of y minus f of y dy. So any questions on how I've set up the integral? Now you have to be careful. Remember, what you now need to do is you have to go back to your calculator and you have to reload these functions in. Again, g of y, I'm going to put that under y1, and then f of y, I'm going to put that under y2. Remember, when you're loading these on your y equals, it's just recognizing a variable, not just an x, not just a y. So g of y, I'm just going to load in an x plus 2. And then I'm going to load in under y2 that e to the x. If you want to look at the graph, you can see the graph is just kind of tilted. The region itself hasn't changed, it's turned. So now when I go to my home screen, again, I'm going to go to my alpha window, and my lower bound is going to be that negative 1.841. The upper bound's at 1.1462. Again, remember, I loaded g of y under y1, so it's going to be my y1 minus y2. And notice you get the same exact answer. All right, so we get the 1.949. Which again, you should get the same area because it's the same region. It's just turned. All right, it's reflected. All right, so any questions on integrating with respect to y? Most of you aren't going to like the integrating with respect to y, but you got to get used to it. All right, because they're very specific. They may ask you to do it one or both ways. Any questions on that? All right, let's take a look at another example. Use your calculator to find the area of region S and R. Now notice they're not being specific in terms of do they want us to integrate with respect to x or with respect to y. So again, notice they're giving me two functions. I've got 2 minus x to the third, which I've labeled in pink. I've got y equals tangent of x. What do you think the first step's going to have to be before you do anything? What do you have to find? You have to find the point of intersection. So we have to find this point of intersection first. So again, when I go to my y equals, I'll type in tangent of x under y1, and then I'm going to type in 2 minus x to the third under y2. Now you can see just by looking at that tangent of x, shrinking this viewing window will help you. Remember, we know we have a vertical asymptote at pi over 2, so I'm just going to change that x max to pi over 2. And again, I'm just going to shrink this down. So you can see a little bit better that this is your region S, this is that region R right there. So again, to find the point of intersection, I'll go under second, trace intersect. And I end up with 0.9022. And like I said, I always write down both. 1.2658. Okay. So let's talk about finding the area of region S for a minute. Obviously, you've already got the equation in the form of y equals. So if you can, we want to do a top minus bottom. So I'm going to let f of x be equal to my tangent of x. G of x is equal to 2 minus x to the third. Remember, I don't know how you loaded them. I put tangent of x under y1, 2 minus x to the third under y2 in my calculator. Can you do a top minus bottom to calculate the area of region S? Yes, you guys go ahead and do that for me. Go ahead and calculate the area of region S. Did we all come up with 1.1605 as the area there? All right. So any questions on finding the area of region S? All right, now let's talk about the area of region R for a minute. So when I look at the area of region R, is it possible to do a top minus bottom? No, it's not. This is a case where even though they're not specifically telling you to do it with respect to x or y, you have no choice. There is no function on the top. So this is a case where you're going to have to do the right minus the left. So again, we're going to have to integrate this with respect to y. So the first thing we're going to have to do is we have to take your two equations and you have to solve for x. So let's take a look at the first equation, y equals tangent of x. How would I solve this for x? inverse tangent. So x is going to be equal to your inverse tangent of y. So then I'm going to call f of y is equal to that inverse tangent of y. Let me take a look at my second equation, which is y is equal to 2 minus x to the third. So now to solve for x, I'm going to have to subtract 2 and divide by a negative, so that's going to give me negative y plus 2 is equal to x to the third. Then what do you have to do to both sides? You're going to have to take the what? Cube root. So x is going to be equal to the cube root of negative y plus 2. So then my g of y is going to be equal to the cube root of negative y plus 2. So now on my calculator, remember what I'm going to do is I'm going to load my f of y under y1. I'm going to load g of y under y2. So my inverse tangent is going to go under y1. And then the cube root of negative y, or negative x plus 2 goes under y2. Just keep track of where you're putting your functions. So now when I do right minus left, which function is on the right? Is it my f of y, which is the inverse tangent, or is it my g of y, which is the cube root? G of y, exactly. So now when I go to find the area of region R, again it's going to be g of y minus f of y. Now remember, what's the lower bound going to be? The bounds now have to be in terms of y. What's the lower bound going to be? 0, because I'm bounded against that x-axis. What's the upper bound going to be? The upper bound is going to be what? 1.2658. Again, remember, I've loaded my g of y under y2. So on my home screen, it's going to lower bound to 0 to 1.2658. It's going to be y2 minus y1. And I end up with 0.729 as the area. So any questions, guys, on finding the area when it's going to be with respect to x or y? All right. So here's a variation of the problem. So if they want me to find a vertical line x equals k that divides the area enclosed by x equals square root of y, x equals 2, and y equals 0 into 2 equal parts. So they're not giving you a picture. You want to make sure you get one. If they don't give you the graph, get it yourself. Well, x equals square root of y. If I solve this for y, this is equivalent to what? Y equals what? X squared. So I'm looking at the graph of y equals x squared from y equals 0, which is just the equation of my x-axis, my vertical line x equals 2. Again, so when I look at the graph of y equals x squared, that's a parabola. Vertex is at 0, 0. And when x is 2, I know the y value is 4. So there's that point right there. So there's my line x equals 2, and then y equals 0. So any questions on how I sketch the graph? Now the question's asking me, they want me to find the equation of some vertical line that will divide this region into 2 equal parts. Well, before I can figure out where this vertical line is going to be, don't I need to know what the area of this entire region is going to be? So first step is going to be to find the area of this entire region. Can I do a top minus bottom on this graph? Yes, I can. What function's on the top? The function's on the top is x squared. The function on the bottom is just 0. So again, to calculate the area of this entire region, it's going to go from 0 to 2 of x squared dx. First, I need to figure out what the area of this entire region is going to be before I can figure out where I'm going to divide it in half. Does that make sense to everybody? So I'm going to have to integrate by hand. So again, when I integrate x squared, that's going to be an x to the third over 3. And then I'm going to evaluate this from 0 to 2. So what is the area of this entire region? 8/3. So that's the area of the entire region. So now what do I want to do with this entire region? I want to take this entire region and do what with it? I'm going to divide it in half, or I'm going to multiply it by a half. So I'm going to take 8/3, multiply it by a half. Set that equal to, what I'm doing is I'm trying to solve for a bound, my upper bound. So I'm going to call this 0 to k of x squared dx. Well, what is half of 8/3? 4/3. I already know what the integral of x squared is going to be. That's going to be an x to the third over 3, and I'm going to evaluate this from k to 0 to k. So 4/3 is equal to k to the third over 3. How do I solve for k? What's going to be the first step? Multiply by 3. So that's going to be 4 is equal to k to the third. So what's k going to be equal to? K will be equal to what? Cube root of 4. So the cube root of 4, if I convert this into a decimal, is about 1.587. So what that tells me, if I sketch the vertical line 1.587, if I was to sketch a vertical line right here, that would divide this region into 2 equal parts. So that's your line, x equals 1.587. So any questions on that example there? You guys go ahead and read this next example and we'll talk about it. Go ahead and read this next paragraph on your own. Between these two curves over this time interval represent. So what happens when I integrate acceleration? It gives me the velocity, exactly. So now let's talk about what is the area between these two curves actually represent? It represents the what? The difference of the two velocities at time t. Because again, if I integrate this acceleration, that's going to give me the velocity at time t. Okay? So it's the difference of your two velocities. That's what the area between those two curves represents. So any questions on example 7? Go ahead and read example 8 for me.